everybody, this is Hibaizat. In today's lecture, I'm going to describe basic terminology for describing data and samples. Then I'm going to explain the difference between numerical and categorical data. Finally, I will explain the difference between time series and cross-sectional data. If we are considering the terms variables and data, in last lecture we differentiated between structured data and unstructured data. Structured data usually have defined size, type, and format. They are inserted or organized inside tables, spreadsheets, and databases. On the other hand, unstructured data are unorganized. It can contain any type or any size of the data. It may contain text, date, currency. So if we are at the first level of statistics, we will deal mostly with the structured data. Structured data is easier in analysis and processing, and also it's easier to extract information from it. So when collecting data, we have different sources of data or different types of variables. Sometimes in business, data are collected without specific purpose. This will end up with a redundancy in data. To collect the data that will help the organization in its analysis, in performing specific tasks. In this case, the data collection process should be very concise and clear. Before collecting the data, you need to specify exactly what are the main purposes for collecting these data. Which data do you need to perform your report or to produce certain analysis results? So if you are collecting data about employees, for example, in this case you may be interested in their names, their birth date, their level of education, their salary, their address, their mobile and emails in order to contact them. If you are offering your employees a health insurance that includes their families, in this case you may need to collect data about their dependents, their wives or husbands, their sons and daughters. However, if you don't provide your employees' families health insurance, in this case if you collect data about their families, you are wasting your resources and you will end up with a large amount of redundant data. In order to deal with data, to know how to read your data, how would you organize them? Before the analysis step, you need to know the following data terminology. First observation is a single member of a collection of items that we want to study, such as a person, firm, or region. For example, if you are collecting data about your employees, if you have 100 employees, you would have data for each employee. Okay, these 100 employees are shaping the 100 observations in your data. The second definition is variable, which is a characteristic of the subject or individual, such as employee's income or an invoice amount. Again, if you are collecting data about your employees, these data include name, age, income, position, and gender. In this case, you have 5 variables. The third definition is data set, which consists of all the values of all the variables for all of the observations we have chosen to observe. Data set to refer to a collection of observations taken as a whole. So the data set in this example refers to the 100 observations, the 100 employees, and their respective 5 variables, which are name, age, income, position, and gender. To make this clear, we insert the data inside a table or a spreadsheet like this one. We have here 8 observations. Each single observation refers to each one of the employees. For each observation, we have different values of the 5 variables. So for the first observation, the value of name variable is Freda. The value of the age variable is 45. The value of the variable income is 67,100,000. The value for the variable position is personnel director, and the value for the variable gender is F, which is short for female. So again, this table represents our data set for the observations. Here in this table, there are only 8 observations with 5 variables: name, age, income, position, and gender. Inside the table, the different values for each observation, different values for the variables of the 8 observations. So structured data are entered into a spreadsheet or database as n times m matrix. We have here n rows and m columns. We have here n equals 8, we have 8 rows, and m equals 5, we have 5 columns. So the data set can be described by the number of variables it contains. We have a univariate data set. In this case, the data set contains only one variable, such as income. Of course, as it's only one variable, we can represent it with a very simple graph like histogram or bar chart, column chart, or pie. The second type of the data sets is bivariate. In these data sets, we have two variables such as income and age. In this case, we can use a scatter plot or correlation. Scatter plot such as XY plot. For the multivariate, of course, in this case, we'd have more than two variables included in the data set, such as income, age, gender. In this case, it would be very hard to represent it graphically, so we represent the relationship between the multivariate data set using some more advanced techniques such as regression modeling. It's a linear model which consists more than one independent variable that affect the respondent or the independent variable. Data are usually divided into two most common types. A data set may contain a mixture of data types. Okay, so here we said the data set, it's a collection of different values for m variables describing n observations. Sometimes these columns, the columns of the data set, may contain different data types. These data types can be categorical or qualitative or numerical or quantitative variables. For categorical data, the value of the variable can be described by verbal labels, such as for gender, they are male or female. Also, if we are describing cars according to model, we may have hatchback, station, or van. These values are verbal labels. For residence, we have villa, chalet, condo, apartment, studio, twin house, shared apartment. All of these are considered as verbal labels. For customers, we can segment our customers as potential customers, new customers, loyal customers, or discount customers. If we are classifying in customer service, we are classifying the complaints received from customers. We may classify them according to the type, maybe as maintenance, maybe as treatment of customer service, maybe problems in the website, or the return policy. So here the value for the variables gender, car model, residence type, customers, or complaints, the values, all of them are verbal labels. Sometimes to facilitate dealing with the categorical variables inside the data set, instead of using verbal label, we may code these variables. For example, in gender, instead of defining the value as male or female, we may insert 1 and 2. 1 refers to male and 2 refers to female. And in this case, we call the value as binary, as it only contains 2 values. For example, for the car models, we may insert 1, 2, 3. 1 refers to hatchback, 2 station, and 3 for van. It's very important to note that in categorical or qualitative data, either using verbal label and coding this verbal label, this doesn't imply any mathematical value. So for the values 1 and 2 that refer to male and female, we can't say 1 is better than 2 or 2 is greater than 1. They are just codes used to refer to our verbal label. We cannot add them, subtract them, do any multiplication or division, and also they don't have any mathematical reference. You can say the difference between 2 and 1 is 1, or 1 is less than 2, or 2 is greater than 1. They are just used for coding purpose. The second type of numerical or quantitative data is usually referring to measuring. In numerical or quantitative, data arise from counting, measuring, some of mathematical or applying, and of course in this case we can apply mathematical operations. So examples of numerical data are financial profits, sales in a specific month, income taxes, savings and expenses, interest paid for loans, profits on bank account gained from interest rate, counting numbers of people infected with coronavirus, also measuring rate of healing, death, and percentage of new cases, new infected cases. So all of these are considered as numerical or quantitative examples of data. There are 2 types of numerical data: discrete and continuous. In discrete data, we always use integer. We use the whole number. No decimal or fractions are allowed. So in discrete, examples of discrete data may be the number of students registered in a specific course, or the number of infected people with a specific disease, or number of sold cars, or number of visits to your doctor. For the continuous data, fractions and decimal numbers are allowed. So this continuous data may contain the time you waited or the patient waited inside the clinic. So in discrete, it's the number of visits regardless of the time you spent inside the clinic. But in continuous, the continuous example is the time the patient waited inside the clinic. In this case, the time may be 1 hour and 30 minutes and 45 seconds, for example. Also, for the continuous, maybe contains percentage of infected people. Percentage may be 90.2%. So here percentage and rates allow decimal numbers and fractions. Also prices of item. The item may cost you 100.95 piasters, 100 pound and 95 piasters. And this would include any financial variable such as profits, taxes, savings, and expenses. All of these variables can permit the value which contains decimal places. It's very important to distinguish between two types of data known as time series and cross-sectional data. For the time series data, if each observation in the sample represents a different equally spaced point in time, we have time series data. So for example, if we collect the daily prices of some stock in the stock market or of the main index, stock index, for example EGX 30, if we are collecting the daily prices for EGX 30, in this case we have time series data. Each observation represents the daily price of the index. And after collecting these daily observations, we are interested to investigate the pattern or the behavior or the changes of these daily prices of these observations over time. So for example, the graph on the screen shows the evolution of bankruptcies between 1980 to 2008. Shows the evolution over time. We have here some patterns. Sometimes the curve goes up and other times it goes down. For few times it's a steady state. It's somehow stable in some points of time. Time series is very important in prediction. If the researcher wants to forecast the future behavior of some variable, for example, the behavior of the prices in the stock market, the behavior of traders and sellers in the stock market. It's very important to study the pattern of the prices over time. Some variables may repeat themselves, or the behavior may be repetitive in future. So time series data are very important for prediction, forecasting, and very important for any study that aims to study the past behavior in order to draw hypotheses or theories. It's very important to study the previous behavior in order to issue a hypothesis or a theory for some phenomena, social or economic or business phenomena. So in data or time series data, the observation is repetitive in different time lags. If we have a budget at the end of each month and we have some number that shows the balance, is there a deficit or is there an excess budget, the monthly balance is considered as a time series. If we are considering the number of students succeeded each year, the annual here we are caring about the year success rate of students, and we have this data for the last 20 years, we can say it's a time series data. The second type compared to the time series data is cross-sectional data. If each observation represents a different individual unit, a person, firm, geographic area, at the same point in time, we have cross-sectional data. So in time series, we are considering the same unit at different times with the same frequency. So if you are considering the price of index EGX30, it's the same unit, and we are considering the price at different units of time. In this case, it's a time series. But here in cross-sectional data, we are considering the price of all the stock markets at some time, at some point in time. Okay, so if we are considering today's price of the 30 stocks included inside the EGX30, and we want to study their behavior for this day, the behavior of the 30 stocks, individual stocks, in this case it's cross-sectional data. Another example, if we are considering employee X and we want to study the evolution of his salary over the 40 past years. In this case, we are considering a single observation, the employee X, and we study the evolution of his salary over the last 40 years. This is an example of a time series data. But if we are considering today and this day in a single time period, we are considering the salaries of all 100 employees in my country. For example, I want to see if some of them have low salary, who has the higher salary, and so on. And I want to represent it inside a graph. In this case, inside a graph, or study them using any modeling. In this case, I have a cross-sectional data. Cross-sectional data that represents the salaries of the 100 employees at a single point of time. Thank you for watching this video.